For problem 21, how many distinct triangles can be drawn using 3 of the dots given below? Because there are 6 dots in total, so we have 6 multiply 5 multiply 4 choices to form triangles. And then because the order of the 3 vertices do not matter, therefore we need to divide by 3 multiply 2 multiply 1. And because the upper 3 dots and lower 3 dots form 2 lines, so we need to subtract these 2 choices. And that gives us 20 minus 2 equals 18. Therefore, the answer is C. For problem 22, we know that the medium size costs 50% more than the small size. We use P for the price. PM is the price for medium size. It equals 1.5 the price of the small size, and contains 20% less detergent than the large size. That's the volume. That means we use V for the volume. The volume of medium size equals 20% less. That's 1 minus 20% equals 80% of the volume of the large size. The large size contains twice as much detergent as the small size. That means the volume of the large size equals 2 times the volume of the small size, and costs 30% more than the medium size. That's the price of the large size equals 1.3 of the price of the medium size. Now we can use these 4 equations to simplify the ratio between the price and the corresponding volume. We first calculate PL divided by VL. It equals, because PL equals 1.3 PM, so we use 1.3 PM, and VL equals 2 VS, so we use 2 VS in the denominator, and we can further use PM equals 1.5 PS to substitute into this equation. That's 1.3 multiply 1.5 PS divided by 2 VS, and that equals 0.975 PS over VS. Then we calculate the ratio of the medium price over medium-sized volume. That's PM over VM. It equals 1.5 PS over 0.8. VL, and because VL equals 2 VS, so we substitute that into this equation. We get it equals 1.6 VS. So we simplify this, we get it equals 0.9375 PS over VS. Now we can see that this ratio is smaller than this one. So the medium size costs less per volume, and then the large size costs less than the small size. So the order is E. The medium size costs less. The small size costs the largest amount. for the unit volume. In this problem, the half semicircle has an area of 2 pi and AB is tangent to sides AC and BC. Angle C is a right angle. Therefore, we can calculate the radius of the semicircle to be r equals the square root of 2 times the semicircle's area, which is 2 pi, divided by pi, and that gives us the radius equals 2. Now we know that AC equals BC equals 2R equals 4. Then the area of the triangle is 1/2 AC multiplied BC, and that's 1/2 times 4 squared equals 8. So the answer is B. In problem 24, the calculator has only 2 keys, +1 and multiply 2. In order to get the fewest number of keystrokes to get an answer of 200, we need to use the multiplication as many as we can, because 200 is divisible by 2. Therefore, we first use 200 divide 2, and that gives us 100. And again, 100 is divisible by 2, so we continue to use 100 to divide 2, and that's 50. Again, 50 is divisible by 2, so we use 50 to divide 2, that is 25. Now 25 is an odd number, so we have to use 25 to subtract 1 to make it even, that's 24. And then we can use division again. 24 divided by 2 equals 12. And similarly, 12 divided by 2 equals 6. And 6 divided by 2 equals 3. 3 subtract 1 equals 2. 2 divided by 2 equals 1. That's where we started. So the answer is, there are 9 steps in total. The answer is B. In problem 25, the square has the length of the side to be 2, and it overlaps with the circle on the same center. The region that are inside the circle and outside the square is equal to the total area of the regions that are outside the circle and inside the square. We can assume that the radius of the circle to be R, and the area that's inside both the circle and the square to be A. From the problem, we know that pi r squared subtract A equals the area of the square, which is 2 squared, subtract A. We can cancel A on both sides. That left us with pi r squared equals 4. So r equals 2 divided by square root of pi. The answer is A.